Now I will do the experiment for this particular diode. I will use this diode now. Now this is used in forward bias. So this voltage now it is variable battery. I have a battery which is variable. You can vary the voltage in steps of zero point 0.1 volt. So in the beginning you can make it 0 volt and increase it 0.1, 0.2, 0.3, 0.4, 0.5. You keep on increase the voltage. It is possible. Now as the voltage increases, let us study about how the current varies in the diode. Now when diode voltage given to it is 0 volt, there is no voltage given, then zero current you will get. There is no current. As the voltage increase to 0.1 volt, you will get zero current. 0.2 volt, zero current. And if you keep on increasing the voltage till 0.6 volt, you can see there is no change in voltage. There is no change in current. And once it reaches the voltage that is 0.7 volt, you can see suddenly the current increased to 20 milliamps. 20 milliampere of current is increased. And this change in current at particular voltage 0.7 volt, and that is called as cut-in voltage. What is that? Cut-in voltage. So what is cut-in voltage? Cut-in voltage is the voltage at which the current increases suddenly, and this is called as cut-in voltage. And if you increase the voltage further here, so at 0.8 volt the current increased even more. For small change in voltage, drastic change in current you are going to get. If you make it 0.9 or 1 volt, the current is almost more than double, triple you will get the current. And after doing the experiment, so voltage and current has taken, and we must plot a graph for that. So I will take voltage along this axis, x-axis, and current along y-axis. And this voltage in forward bias is called as forward voltage, and the current we are getting, that is in the order of milliampere. Now as the voltage is increasing till around 0.7 volt, there is no current at all. But once you reach the voltage called as 0.7 volt, the current increases suddenly. So for small change in voltage, the current increasing suddenly, and this particular voltage at which the current increases suddenly is called as cut-in voltage, or it is also called as knee voltage. The knee voltage is also a cut-in voltage only because it is looking like a human knee. That is why it is also called as knee voltage. And this characteristic is called as forward characteristic of the diode. And why does this happen? Till 0.7 volt you are not at all getting the current. Current is zero till here. Why is it so? It is because here, look at this diagram. If you keep on increasing the voltage till around 0.6 volt, what happens? These holes and electrons, that is majority charge carriers, have not enough energy to overcome the barrier potential. This is the barrier, and barrier potential has a potential 0.7 volt. That is why it cannot able to cross the junction. Once it cannot able to cross the junction, you will not get the current till there. But once it reaches 0.7 volt, you will get a sudden current in it, because depletion layer at 0.7 volt becomes zero. There is no depletion width. That is why you will get a sudden change in current. And this is 0.7 volt for silicon. If you are using silicon semiconductor, you will get 0.7 volt, sudden change in current at 0.7 volt. But if you are using germanium At 0.3 volt itself you will get the sudden change in current. From here only you will get the sudden change in current if you are making a diode with the help of germanium. Okay, this is about the forward characteristic of the diodes. Now let us concentrate on reverse characteristic. So VI characteristic, in which forward characteristic we already studied, and next one is reverse characteristic. Reverse characteristic means the diode should be used in reverse bias. Why it is reverse bias? Because you just see the N side is connected to positive terminal and P side is connected to the negative terminal of the cell. That is why it is reverse bias. In reverse bias, what happens? We will do the experiment. If you connect in this fashion in reverse bias, and this voltage is again variable voltage, variable battery which is connected. Now I will change the voltage here in the steps of 1 volt. I will make it 0 volt in the beginning, 0 volt, 1 volt, 2 volt, 3, 4, 5, 6, 7. I will keep on changing the voltage. Now I will note down the corresponding current also. When you make it 1 volt, there is no current. When you make it 2 volt, no current. 3 volt, 4 volt, till around 7 volt, you are not at all getting any current in a reverse bias. You will not get any current in it. But once it reaches a voltage, here it is 8 volt, at which the current increased suddenly, right? Around 60 microampere of current you got it. And this particular voltage at which the current increased suddenly in reverse bias, it is called as breakdown voltage. It is called as breakdown voltage. So what is breakdown voltage? The breakdown voltage is the reverse bias voltage at which the reverse current increases suddenly, and that is called as the breakdown voltage. Break, here the term break indicates that inside this semiconductor diode there are silicon or germanium atoms. If it is made up of germanium atom, or maybe impurities were added in it, what happens? If you keep on increasing the voltage, what happens? These bonds, the bonds of germanium and impurities added, will break. After breaking, some electrons will become free, and that produces the current, and that is why the term here break. So breaking of covalent bond indicates breakdown. And now we will plot a graph of voltage versus current. Always we must take, in reverse bias we have to take in third quadrant. The curve should be in the third quadrant. Why? Because in forward bias, how the battery was there, now it is reversed. The battery is changed over, right? It is reversed. That is why we are changing the plot also in negative direction. Negative x-axis we are going to take the voltage. Now, just by looking at these values we can plot a graph. As the voltage increases, reverse voltage increases, what happens? The current is 0. Our ammeter, any meter if you use it here, that is microammeter if you are using, that will not show any current in it. So it is 0 current. But practically you will get a little current like this. So the curve is not along this particular x-axis, right? But it is little current is there, and that is because of minority charge carriers in it. Because the minority charge carriers can cross the junction. After applying the voltage, these minority charge carriers can cross, that produces a little current, and that is shown here. And that particular current is also called as dark current. That is called as dark current, and that is due to minority carriers. So as the voltage increases, the current is almost zero, that is registered by our ammeter, and this current is almost constant till the voltage reaches. And this particular current, which is constant current, is called as saturation current. The current is already saturated, you will not get a current increased. But once if you reach a voltage, that is 8 volt, right, after that the current suddenly increases, and that voltage at which current increases suddenly in reverse bias is called as breakdown voltage. So remember what is breakdown voltage in reverse characteristic. This is what the reverse characteristic. So we have three terms we studied. One is breakdown voltage, and we studied cut-in voltage in forward characteristic, and saturation current. It is also called as reverse saturation current. Let me summarize it in the next topic. The summary of these two graphs can be showed in a single graph.